right, let's see what we can figure out on this one. So I like the way that you started this problem, but let me back up to the beginning. So I know that if this is to be a parallelogram, the two halves of the diagonals have to equal each other. So in other words, 4x plus 4y has to equal 12. They have to be the same length. And I also know that y should equal 4x minus 17. Again, if this is to be a parallelogram, the two halves of each diagonal have to equal each other. Or in other words, the way the rule is stated is that the two diagonals bisect each other. They cut each other into equal halves. So y has to equal 4x minus 17. Okay, so the ways you can solve this are either with elimination, the one where you add the two equations together, or with substitution. And because of the way this one is set up, I'm going to use substitution. Y is equal to this stuff. Well, if I go to the first equation, and instead of writing y, I write 4x minus 17, which is the same thing, then I get an equation I can actually solve that's only going to have one variable. So 4x plus 4, and instead of writing y, I write this whole thing 4x minus 17. I like to put it in parentheses just to make it, to separate the y from all the other stuff a little bit. So 4x plus 4y equals 12. Now this equation only has one variable in it, just x. That means I can solve this equation. So distribute and go from there. 4x plus 16x minus 68. Maybe? Yeah. Equals 12. Combine like terms, etc., etc., etc. And I can solve that one for x. Oh yeah, and once I find x, like if x was, I don't know, 5 or something, then I come back here and I plug in my x value and I solve for y. So again, what I've done here is called the substitution method. When I've got two variables, I will have to combine two equations, either using substitution or I can use elimination, which again is the one where you add the two equations together. But first you have to line up your x's and y's and stuff. So hopefully this helps you on some of those parallelogram problems.